Hi, everyone. I'm really sorry that I'm not able to be with you in our live class today. A couple days ago, or I guess maybe a day ago, I was notified that I was um, able to get an appointment to get the COVID vaccine, and so that's where I am this afternoon. So I have this recorded lesson for you to go through what we're going to learn today about the law of cosines. The first thing that I want you to do is open up the document that is called Investigation Law of Cosines. And it's going to look similar to what you can see in this video right now, what I'm showing you. There is a Google slide presentation, and you'll open that. It's got a couple of practice problems. You'll open that later. We're going to start with this today. I had planned that you would do this in small groups, but because we're not having a live class, I'm going to have you work on this independently, and then you'll come back to the video to get the answer for this. So anyway, we're going to figure out how can we develop the law of cosine. So last class we learned about law of sines, and those were for acute triangles, and law of cosines looks like an acute triangle too. And so you're going to work through the investigation to derive the law of cosines. So it goes through and gives you some steps in here. So it first talks about, remember, the altitude is going to be this line here, line K, all right? And so it's talking about how the altitude is separating the triangle into two triangles. It gives you the steps, so you're going to be using Pythagorean theorem. The one thing I want you to be careful with, I believe on one of the steps it asks you to expand like a binomial when you multiply it. I think it's step 3. So I want you to be careful on that, okay? So I want you to pause the video and work through the steps on this document. You can do your work right on the document, work through the steps, and when you're done, come back to the video because I'm going to go through the solutions for this. So pause the video and get started. All right, welcome back. So I hope that investigation was fun for you, and I hope that you were able to complete it. So let's look through the steps here. So step 1 says the altitude separates triangle ABC into two right triangles. So I know that I have a right triangle here, and that makes that a right triangle as well. So they're asking us to use the Pythagorean theorem to write two equations, one relating KB and C minus X. So this is one. And then another one relating A, K, and X. So for my first one, I'm going to write K. So if I'm looking at, we'll make this my pink triangle, and I'll do a different color for the other one. So for this one, that means B is my hypotenuse. So I'm going to have B squared is equal to K squared plus, and now this C minus X, that's that length there from A over to the altitude. I have to put that in parentheses and then write that it is squared. For my other triangle, I'll do that one in blue. So A is my altitude here. And so for this one, I'm going to have A squared is equal to K squared plus X squared. Now, step 2 says, notice that both equations contain a K. So they both contain a K because they have that shared leg right there, right? So we're going to solve, or K squared, we're going to solve each equation for K squared. So with my first one, I just need to subtract that C minus X squared from each side. So I'm going to have B squared minus, and then remember that has to stay in parentheses, C minus X squared is equal to K squared. For my other one, I'm just going to have to subtract X squared from each side. So I'm going to have A squared minus X squared is equal to K squared. Now keep that in mind. So now step 3, since Since both of the equations in question 2 are equal to k, they can be set equal to each other because k squared is k squared, right? So we're going to set the equations equal to each other to form a new equation. So for step 3, let me scroll back up so I can see. So b squared minus, and then in parentheses, c minus x, close your parentheses, squared, is equal to a squared minus x squared. Step 4 says notice that the equation in question 3 involves x. However, x is nowhere on that triangle. So as a result, we need to attempt to rewrite the equation in question 3 so it does not include x. So to start this, we're going to start by expanding c minus x squared. This was what I was talking about before. Be careful. So that means it's c minus x times c minus x. And if you need to use the area model for this, you can. So you have c minus x, c minus x. And then in your boxes, this would be c squared. This would be minus cx, c times negative x. Remember, these are multiplication, not subtraction. Minus cx, and then negative times negative gives you positive, plus x squared. So when we expand this, we have c squared, that's 2 negative cx's, so minus 2cx plus x squared. Number 5, let's make sure we did everything there. Yeah. Number 5, step 5, says solve the equation in question 4 for b squared. Okay, so we're going to solve, so we did not substitute that back in, so let's rewrite that with the expansion. So b squared minus, now this all needs to go in parentheses because it's subtraction right there. C squared minus 2cx plus x squared, close the parentheses. I'm just subbing this in for that c minus x quantity squared at the top, is equal to a squared minus x squared. So this is saying solve this now for b squared. Okay, now this minus out here means that everything inside the parentheses becomes its opposite. So we need to first rewrite that because that's a big mistake people make. So it should be b squared. Now it's minus c squared because that's its opposite. Minus a negative means plus 2cx minus a positive, that means minus x squared. So I'm just distributing that negative or that subtraction right there to make sure that I don't forget to change a sign anywhere. So now it's told me that I need to solve for b squared. So I'm afraid I'm going to run out of room. I'm going to add x squared to both sides. I'm going to add c squared to both sides. And I'm going to I'm going to subtract. Let's subtract that. Subtract 2cx. So over here, I'm going to add c squared. Same thing I did on the other side. I'm going to subtract 2cx, and I'm going to add x squared. And so now I need to combine that. So I'm going to have b squared is equal to, so I just eliminated all of this and all of this. Okay, so I'm going to start over here with my a squared. I have a negative x squared and a positive x squared. I know that if I put those together, it gives me 0, so I don't need to write those down. Plus c squared minus 2cx. So this is my part 5. It's where I needed to end up. Okay. If at any time you need to pause the video, please do. Okay, step 6 says the equation in question 5 still has an x in it. True. So to eliminate the x from the equation, we will attempt to substitute an equivalent expression for x. So it says write an equation involving both cosine of b and x. And then thinking about why are we using cosine of b. So I'm going to go back up and look at my triangle. So here's angle B. And we want to write an equation involving cosine of b. And the reason we're doing cosine of b, because it said to use x in this. So that's my adjacent side and my hypotenuse. Did it say to use the a? Yeah, it just said cosine of b and x. Okay, so we're going to write cosine of b. Remember, cosine is adjacent over hypotenuse. So the adjacent side was x, and the hypotenuse side was a. So cosine of b is x over a. Step 7 tells us to solve the equation from question 6 for x. So we want to get x by itself. So that just means we're going to multiply both sides by a. And those a's reduce. So we have x is equal to a times cosine of b. Step 8, we're almost there. Step 8 tells us to substitute the equivalent expression for x right up here into the equation from question 5. So let's go back and see what we had from question 5. Okay, so it was this b squared equals, I got to write that again, b squared equals a squared plus c squared minus 2cx. And what we want to do is take this right here, take that and sub it in for that x right there. So we're going to have b squared is equal to a squared plus c squared minus 2 times c times a times cosine of b. Now, we need to clean this up a little bit. Really, I just need to I like those variables to be alphabetical. So it should look like this. B squared is equal to a squared plus c squared minus 2ac. We just want that alphabetical. Times cosine of b. This is the law of cosines. So if we want to know a side of a triangle or an angle of a triangle that is an acute triangle, we can use this. Now, there are different versions of this because depending on what we know. So that's step 9, saying use a similar method. 2 other forms of this law can be developed for a squared and c squared, so that those would be what's equal to. So if we look at this right here, I just want you to look for some patterns here. So we have b squared here, and then we have sine of b. So whatever this is right here, it's cosine of that letter. And then the a and c, we square those sides and then minus 2 times that. So if we think about it in that way, if we wanted to know what a squared was equal to, we know that out here it's going to be times cosine of a, uppercase A for that angle. And then we haven't used b and c yet. So it would be b squared plus c squared minus 2, and then bc again, 2b times c, then times cosine of a. If we wanted to do this, we did a squared, we got b squared. Let's do it for c squared. This is the one we see mostly. So c squared, and then out here we know we're going to have cosine of angle c. So we're using c squared. So now we got to put a squared plus b squared minus 2ab times cosine of c. Any of these can be used. And what you're going to see with our practice problems today, that they might not have a, b, and c like that at all. But what we're looking for is the pattern of the angle, and then its opposite side, that's what goes out here, and then the two adjacent sides to that angle, okay? So what I would like for you to do now is take a breath, because that was a lot. And I want you to open up the document called Law of Cosines. This is a Google Doc. So I want you to open this up. If you need to pause, take a breather, stand up and walk around, because that was a lot of information to take in. And when you come back, the first thing we are going to do is cross off the warm-up, because we're not going to do the warm-up today. So just cross that off. You'll see that again another time. Okay, so let's get rid of that. And then scroll on down. Law of Cosines investigation. That's what we just did. Remember, I said I just found out I was going to get this appointment, and so I had this all set ready for us to be in person in class. And go with me to page 3. I've got 2 examples here for us to do together, and then I've got some practice work on here for you to do on your own. So go with me to page 3 right now. And on page 3, it gives us triangle CTR or CRT, and it asks us to find the length of CT. Now look, there's no A, B, and C here. There is a C, but it's not the angle. So this is what we want to find, and this is the angle that it's across from. So let's think about when we did law of cosines, like if we had C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. Well, we don't have angle C, okay? So it's not going to work out like that, okay? So we're going to rename this. So what we're looking for is side R. So I'm going to put R in here. And we're allowed to do that, R squared. And then over here it's going to be cosine of angle R, because that's what we're looking for. And then the other 2 sides that we don't have are C and T. So C squared plus T squared minus 2 times CT. So we're just looking for those patterns, okay? Now, once we have that set up, now I know we're going to have some big numbers and it's a lot, but once we have that set up, then we can start substituting numbers in and work this out. And it's going to take a little bit of space. So I'm going to start writing all the way over here. R squared is equal to, for C, I need to substitute in 45. For T, I'll substitute in 52. Remember, those first 2 are squared. Now it's minus, and then it's 2 times C and T, so 45 times 52. And then cosine of R times, don't forget to write that cosine, of 36 degrees. Now we just start with order of operations and go slow. This is where people make mistakes, so slow down, slow your roll here, and just take your time. So 45 squared is 2,025. And again, like if you got this and you're like, I want to try this on my own, pause the video and try it on your own, and then come back and check. So 52 squared is 2,704. Subtract, and then we can multiply all this together, 2 times 45 times 52. That gives us 4,680. And I like to wait to evaluate cosine of 36 degrees. I just like to do the other stuff first. Okay, so now we're going to add these together, and we get 4,729 minus, and now we can multiply 4,680 times cosine of 36. And when we multiply that together, we get 3,786.2. We do our subtraction. We get 942.8. And then take the square root of both sides. Don't forget that last step. So R is going to be approximately equal to, we get 30.7, or we could say 31 centimeters. So a lot of steps. You have to show your work. You've got to show the steps and show the work, okay? That's if you're finding a side. We're going to try one now where we don't have any angles and we want to find an angle. So go with me to page 4. Again, pause the video as you need to. On page 4, we're going to find the measure of angle Q. This is what we want to know. And so the opposite side is lowercase q. Remember, the opposite side of angle D is lowercase d. The opposite side of angle E is lowercase e. So I'm going to start again with the original law of cosines. So c squared is equal to a squared plus b squared minus 2ab times cosine of c. I don't know what, like, I don't have a C. I don't have A, B, or C at all in here. Sometimes maybe that's a little bit easier because it's less to get confused with, but I do have a Q. And so that's what I'm looking for. So I need to have that Q in here where that C is. So that means it's got to be Q squared right here. So we're going to substitute in with the letters that we have representing sides and angles here. So this will help us out. And so we know we've got to have cosine of Q. And so that means we haven't used E or D yet. So we'll do E squared plus D squared minus 2 times E times D times cosine of Q. You could have done D and E, D first and then E. That would have been fine. And now we start subbing in numbers. So I'm going to start way over here because I know I'm going to go all the way over to the side. 250 squared is equal to, E is 175, so 175 squared, plus D is 225, so 225 squared minus 2 times 175 times 225 times cosine of Q. We're going to end up having to use the inverse button because we don't know what Q is. So let's square these numbers. So we get 62,500 for 250 squared. 175 squared is 30,625. 225 squared is 50,625. I'm going to do all that multiplication there together. So 2 times 175 times 225 is 78,750 times cosine of Q. Let's go ahead and add those two together, bringing down our equation. So 30,000, 50,000, that's going to give us 81,250 minus 78,750. Remember, this is times cosine of Q. I bring that up because you can't subtract these. You've got to follow order of operation. So you have to multiply and then you can subtract. We can't do that. So what we have to do is we're going to have to subtract 81,250 because we do want to get that cosine of Q by itself, but we can't subtract those numbers. So we subtract both sides by 81,250. We're going to end up with a negative number over here on the left-hand side. We end up with negative 18,750. But just watch how nice this is going to turn out. So now we bring down, so that right there gave us 0. We bring down the 78,750, but look what's in front of it. Bring down that negative with it. And bring down that times cosine of Q. Now watch what happens here. To undo that multiplication, we divide. And look how nice that is. So we're going to have a negative divided by a negative, which is just perfect. So that's going to give us a positive. That 5 there doesn't look very good. Let's fix that. Okay, when we divide negative 18,750 by negative 78,750, we get a positive 2381. Go 4 places if you're rounding. Don't just do 0.2 because your answer is going to be way off. That's equal to cosine of Q. So that means that we do the inverse of cosine, put in 0.2381 to get what Q is. And when you do that, you get Q is approximately 76 degrees. Now I want you to look with me at the independent practice. For exercises 1, 2, and 3, you're going to find the length to the nearest centimeter. So these are all like example 1. Okay. And none of these are like A, B, and C. So you're going to have to use those variables, use the letters that represent the sides and the angles to figure out, like start with the original and then start with that. Exercises 4 through 6, it's asking you to find the measure of the angle. So these are all like example 2. Again, no A, B, and C here, so you're going to have to look at what you're finding and then use the substitute those sides and what the letter is that's representing the sides and the angles to rewrite that to make it pertain to your problem. And then I thought, just for fun, why not show that sine of A divided by or over cosine of A is equal to tangent of A. So with this, the only hint I'm going to give you with this is thinking about how we name the ratios opposite, adjacent, and hypotenuse. So gives you a little bit of doing a little bit of algebra gymnastics here with your mind and thinking about how you can show that it is equal to tan of A. And if you can show this and you can do this, then I have, if you like puns, I have a little pun that I'll show you that goes along with this. So I hope you all have a great day. I hope you have a great weekend. I will have office hours on Monday from 3:05 to 4. So if you have questions about any of this that we're learning, please come to office hours to get some extra help with that. Okay. Have a great weekend.